So Android is not an operating system, first of all. So Android means, the basic definition of Android means a machine which can talk to a human. That is called Android. So you can take it as a robot, or you can say as a mini computers. You can take any example. So that thing is called an Android. So Google owns a name of Android in the name of the machine which can interact with the human in any other language or any of the you can say audio or visual backfeed. So now let us give an overview that what is the Android and how the Google knows the name. So starting with the Android. So first of all, the Android, it's an OS by the Google, which is an open software platform, and it is available for different mobile devices. It is based on a Linux kernel. So it is not a Windows-based kernel. So it's a Linux-based kernel, which is developed by Google. And later on, OHA, that is Open Handset Alliance, acquires the Android. So Android was specially designed to design the Android applications only. So now till date, so there are about 4 million. So this is actually you can say a past number. So now it crosses to trillions of apps in the Android market. So you can search any of the apps on the Android market. So because of the Android of an open source, so it is easy to use, and you can also develop an application free of cost. So what is the origin of Android? So firstly, the Android was originated, or you can say it is founded by Paul Alto in California in October 2003 by Andy Rubin, Rich Miner, and Nick Sears, and Chris White, who worked for the Google as a developers. So these were the 4 persons who actually came to a knowledge about Android. So they have developed, or they have founded the Android as a operating system in late 2003. And later on, Google had developed, or you can say Google has purchased the Android as a software in 2005. So now 2005 onwards, Google owns the Android software. So mainly the Android is based on a Java language. So I think you know about Java, because the prerequisite of knowing the Android is Java. So anybody is not comfortable with the Java, I don't think that the person is able to recall what is Android or how the Android works. So that's a basic prerequisite of Android, that you should know Java. So Android has its own virtual machine. So virtual machine named as a DVM. So if you recall about the app keeps on crashing. So it generates an error as some DVM error. So that DVM, the full form of DVM is Dalvik Virtual Machine. So every app inside the Android smartphone works in its own environment. So the apps are isolated from other apps. So that is why it is called a virtual machine. So which is executing on an Android platform only, because that DVM is designed for Android purposes or Android applications. So now the OHA, that is Open Handset Alliance, a standard that several companies has actually formed an organization on late November 5, 2007. So they have come into a conclusion that we have to make an open source software, so that many of the mobile devices or a smartphone can work on a common platform. So it was the first Android beta which was released on November 12, 2007. So here you can see that in 2007, so the first beta Android version was released. So this slide actually tells you about the OHA, that is Open Handset Alliance. So Open Handset Alliance is a business alliance of a firm to develop open standard for mobile devices only. So it devotes to advancing the open standards for mobile devices, so that anybody can code and anybody can publish their own apps on the store. It also develops technologies such as which will be significantly lower cost of developing and distributing mobile devices and services. So that's a basic, you can say, standard which has been opened by the Open Handset Alliance. Also, the Open Handset Alliance includes various, you can say, companies. So the companies, you can name any of the companies till today now. So companies like Asus, Intel, Nvidia, Vodafone, eBay, Huawei, any of the, you can say, companies, they are all associated with the OHA, that is Open Handset Alliance. So they have come to a conclusion that they will support the OHA on the open sources applications. So based on the Android, so Android has various versions associated with it. So it was first beta release was released on November 15, 2007. So later on, the stable versions were released as alpha and beta. So A, B, C. So they have named on, you can say, alphabetical order. So A, B, C, D, and up to so on. So the first two, that is A and B, was the alpha and beta in phase. So they have no their names associated with the Android. So they have a stable version named after C, that is Cupcake, which was released in April 2009. So from Cupcake onwards, they have their own name, that is D for donut, eclair, E, F for froyo, G for gingerbread, honeycomb, and so on. So till now, we have received Android version as latest by in 2018, named as Pi. So Android Pi is the latest version. So as you can see the trend, so each and every year, so they have released a new version of Android. So starting from A till now, we have reached till P. So P is for Pi, Android Pi. So if we go into deep, so what is the Android architecture? So I will discuss here the four basic layers of Android. So how the Android was built and what is the architecture behind it. So there are four layers. So first layer is called application layer. Second layer is called application framework. Third layer is called libraries and runtime. And fourth one is called kernel. So let us discuss one by one by visualizing the stack. So this is a stack that will be related to the Android. So as you can see, the red highlight, so that red color gives you the idea about the Linux kernel. So that's actually a heart of the Android. So here you can see that display driver, camera driver, Bluetooth driver, and various other drivers are there. So you can use them by using their drivers, but you cannot alter the code. And moving above, we have libraries associated with the basic drivers, and we have a separate, you can say, a region for a Android runtime. So Android runtime is kind of a thing that will be discussed in the later slides. So that's a separate area where the Android code will be able to run. And the moving above, we have application framework. So in the application framework, we have Activity Manager, Windows Manager, and various other managers associated with the Android code. So this is a layer where the application framework will be designed. And moving above, we have application where we have a design a UI which can interact with the human, or you can say which can interact with the user. So let us discuss each and every layer in detail one by one. So first layer was, which is in the bottom, it was kernel, that is Linux kernel. So that Linux kernel supports a display driver, camera driver, Bluetooth driver, various other architecture. So where the architecture is based on a Linux 2.0 kernel. So this is an old version of a kernel. So nowadays these days it has been upgraded to latest version of a kernel. So this layer is a core of Android architecture. You can say it's the heart of Android, which provides the services like power management, memory management, security, and etc. It also helps in the software and hardware binding for better communication. So various other drivers which are responsible for booting up the hardware. So all the libraries that are there as a driver is located at the kernel level. Moving above, we have native libraries. So native libraries as Media Framework, SQLite, SGL, SSL, FreeType, OpenGL. So these are the libraries which are there in Android. So, and all of the libraries are actually written in C and C++ languages, all of the native languages. So these libraries cannot be accessed directly. So many are the libraries like the web library to access the web browser, libraries for Android and video format, etc. So to run any of the libraries, you require some library which are there already there in the Android. So these are the libraries which are there in the Android, and you cannot change the code. You can say a source code of the native libraries, but you can access by some you can say by some interfaces. So inside that thing, we also have a Android runtime. So that runtime requires Android core libraries and DVM. So I have discussed the DVM. So DVM is a dynamic virtual machine. So Android runtime was specially designed for Android to meet the needs of running in an embedded environment where you have limited battery, memory, and CPU. So here you can actually able to run the apps in the Android environment, which is actually a virtual environment for Android. So Dalvik is a process virtual machine in Google operating system, is a software that runs an apps and Android on Android devices. So this will be running on only the Android devices. So the programs are commonly written in a Java and are compiled in a bytecode. So purely to access the core libraries and to run the DVM, you require a Java. So that Java code will be you can say write in the front end, and you can compile back into bytecode to execute it. So moving further, we also have a application framework. So application framework has many of the managers. So you can see in this slide, activity manager, window manager, resource manager, location manager, telephony manager. We have n number of managers. So all are written in a Java programming language, and the application framework is a toolkit where these all application will use. So these applications include the ones that comes with the phones, like home application or the phone application. So these are the manager which are already there inside the Android. So all the apps use the same framework as the same APIs. So if you are using, say, location manager, so some location manager is using some API version. So that API version should be supported by the corresponding smartphone. So if the smartphone is having a version lower than the desired API level, which for the location manager, so that app will not able to work. So it should be greater than or equal to the version which is being designed for a particular manager. So that smartphone should be capable of. So moving further, we have application layer. So in the application layer, that's a kind of a UI, or you can say a UI for the application. So we have home, dialer, SMS, IM, browser, album, clock, email, and number of apps. So it includes the home application like the contact, browser, and apps. All of the applications like camera, Google Maps, browser, SMS, calendar, contacts. So they are all native apps. So these application works with the end user with the help of application framework to operate. So this is the application layer, so through which we can interact with the hardware. So here we are also having a gist of our knowledge that this application layer will work only when we coded our application in a Java environment. So Java is the middleware between the UI, that is a human interaction, and with the backend, or with, you can say, interacting with any of the hardware. Obviously, there are some security things which are being added in Android. So Android is kind of a multi-process system in which each application run its own process. So its own process, it means in each of the environment, its own environment, that is in the DVM. So most security between the application and the system is enforced at the process level through which the standard Linux facilities, such as the user group IDs that assigned to the applications. So there are some, you can say, rules and regulations which are there for the security. So the Android has actually empowered the security patches. So they have also releasing a security patches by month to the various Android devices. So they have facilities so that nobody can hack, or you can say nobody can have a full access on the Android, you can say, smartphone. So it is designed to have a multi-layer security. So there is not a single layer. So there are multi-layers for a security, which provides a platform flexibility. And when the attacker attempts to attack on a device, the Android platform helps to reduce the portability of the attack. So the attack will not be possible because of the multi-layer thing. So now, moving on further, we have some key points of the Android security. So key points we have to note down that we have a design review where the security model is designed. It will be reviewed by the developers, so that risk level may be very less. The code review and the penetration testing. The goal of this code is to review to check the system strongness against the various penetration testing technologies. Open source and the community review. So Android users open source technologies that have significant external reviews, such as the Linux kernel. And last one is the incident response. So the Android team enables the rapid mitigation or vulnerabilities to ensure that the potential risk of all the Android users are minimized. So they can't eliminate but they can minimize the security risk. So obvious, using the Android, we have some advantages and limitations with that. So what are the major advantages is that we have a ability for everyone to customize the Android platform. It lets to you choose what kind of hardware you can use. It has a better app market as compared to other vendors, a more mature platform, and it support all the Google services ranging from Gmail to Google Reader. Obvious, there are some disadvantages. So one of the disadvantages is that the Android market has less control of the manager. Sometimes there are some malware in the Android market. So Android market is actually you can say a repository where the all APKs or all the apps which are there, so they have a very less control by the manager. So some malware can be inserted in the Play Store. So that's a main disadvantage because of the less control. A lot of process running in the background, which reduces the battery life and quickly drains. So that's a major issue because the Android supports a multi processing technique. So in the multi-processing, so the processes are running at the background. So when you run different processes at the background, so obvious that requires computational power. So that computational power is drawn out from the battery, so which is drained quickly. So it also have a inconsistency with the design among various other apps. So when the API level, or you can say the version changes, so that app may not support the Android apps more. So moving further, we have some limitations. So limitations is that we have to develop in a Java only, so because that's a prerequisite of Android. So Android SDK is also required. So Android SDK is a software development toolkit where you can actually write, or you can say actually edit your project, and you can actually run that particular file on your smartphone. And it also requires a continuous internet connection. So that is a limitation for using the Android in the further in future. So obvious, we have a large support for the Android because as we having Android applications in the Play Store, or you can say in the Android market. So we have lots of applications. So you can install any one of them and you can ready to use because of the you can say open source software. So anybody can code it and anybody can push the that compile code onto the Play Store, and anybody can install it to get the features. So this is regarding the Android applications. So how the Android was evolved from scratch till now, and what are the you can say layers which are there associated with the Android. So these are the references. You can refer it down. You can actually write it down so that you can actually get a knowledge about what is Android and what is how the Android works.